Okay, this chapter is a multiple regression estimation. So we will have several multiple regression session, but actually the one representative statistical model is the multiple regression. That's why we will spend a lot of time on multiple regression, but this is the first chapter of the multiple regression, how we estimate. Okay, multiple linear regression model has this form. So actually this is exactly same as our previous section, the simple linear regression model, but only difference is we have more than one predictors. We have more than one independent variable. So we can have a 2, 3, 4, 5, many different independent variables. Still, we will have a one dependent variable, one explained variable, one response variable. So other than that, it's exactly the same. We will have a u, which is the error term, same way, and we will estimate our dependent variable y using x1, x2, x3, x4, and so on. So motivation of multiple regression analysis is what if we need more than one variable, right? More explanatory factors we can put into our model. So actually what the coefficients means is what is the effect of our factors if all others are stay the same. And then we can create it a lot more flexible functional form. So actually, even though we say this is the linear regression, but actually we can handle some nonlinear term also. But we will create the nonlinear term and then handle that nonlinear term as a new variable, and then mathematically this regression itself will be just linear regression. Okay, so this is for example, we trying to predict the wage, how wage is it, and then this is the intercept term, and then education and experience. So if we trying to figure it out, who get higher wage, who get the lower wage, maybe it will be depend on the education level and also the experience level. So here the B1 is what is the magnitude of the effect. So at year of education increased by 1 year, then how much the wage will goes up or goes down. What does it mean? The explicit means is if we hold experience, everything else, actually we have only two things, but even though we have like a way more other factors, we hold everything fixed, and then we change only education. If I increase the 1 year of education, how much the hourly wage go up or goes down? That is what the beta 1 means. And beta 2 is also what is if we increase the experience 1 year more, then how much my wage goes up or goes down, but all other factors fixed. So education, year of education is fixed, all other things is just stay the same, and if I only change this variable. Okay, this is another example. So average test score and per student spending. So average score will be the beta 0, which is the intercept, plus beta 1 times expand the per student spending at this school. So school spend money per student. So how much the school spend money, and also average income of the family of the student at this school. So different school has a different family average family income, and then so actually both of them are like the money. So is it the money the richer school there a higher average score or not. If you want to see, then you can think about it. The problem is this expenditure and the average income may have some correlation, right? So the richer town, average family income will be higher, and then the school inside of that rich town may have enough finance, so they can spend more money on it. So this is we will talk about that today. Also later we will talk about it a lot. But what if there is a correlation between my two factors? So if we taking out this average income part, then actually if we take this out, then this beta 1 and beta 0 will change. I don't know it will go up or go down, but actually depends on the correlation. This beta 1 and beta 0 will be changed, and then we call this is biased. Why we call it biased is because if this is the real relationship, and then we're taking out one of the important factor, then actually it will affect the all other factors. Beta 1 and beta 0 will change. Well, we don't have to worry about these things in the simple regression model, right? So everything was in the error, but now since we can handle multiple factor, if we take it out to the one factor, actually we will have some biased estimator of the beta 0 and beta 1. So we have to keep in mind, depends on how you decide which factor we're gonna include will affect your estimate. Okay, this is the another example. Family consumption will be the function of family income and family income squared. This is how we handle the actually non-linear relationship. We created a variable family income square, and then handle this family income square as the new factor. So mathematically, even though it has a square, then you can just consider this is just one variable. Then we can still, this will be the linear regression. Even though we practically we can handle some nonlinear effect. Right? And then how much does the consumption increase if income is increased in the 1 unit? But problem is here the income increase, here the income square also increase. But remember actually the beta 1 is if we can hold all other factors. So here beta 1 is if we hold this income square the same, if I can only increase this income by 1 unit, how much my consumption increase? But actually that is impossible, right? Can we hold the income square the same and then increase the income by 1 unit? That's impossible. If you increase 1 unit here, this will increase too. Therefore now the interpretation will be a little different. So how much the consumption increase if income increase, then you have to think about this way. Actually, you can consider this is like that's why this is like not exactly the derivative. Right? So if you take a derivative of this function respect to the income, then you can have a beta 1 because, right, plus 2 times beta 2 times income. So now the interpretation will be mathematically, if you handle the income and income squares differently, still beta 1 is the meaning of beta 1 is what if I hold everything including the income square, all other factors fixed, and then if I can increase only income by 1 unit, how much my consumption will change. That's a better one. However, practically it's impossible to increase only income without increasing income square. So if you really want to know the how much the consumption change by increase of 1 unit of income, then you have to calculate something like this way. And of course we can handle log also. You can, depends on the problems, you can apply the log to the independent variable or the dependent variable. This is the independent variable. You can apply log. You can apply log. Again, here the log is not when the computer calculated the beta 0, beta 1, beta 2. Computer doesn't care that's a log or not. The log says that's a new number, so the computer handle that is just a new factor. Same way, this is the it's a relation, but still the computer, this regression itself will consider this is just a one new factor, so still we can say this is a linear regression. That's why the meaning of the linear regression here, model has to be the linear in parameters. That's what it means. It's not in the variable. So variable can be something square or like a log. That's possible, but against this parameter. So I'm not saying the parameter has the square or something like that, but in parameter everything is just a one factor. This is one factor. This is one factor. So that should be the linear. But still, practically, by meaning we can handle nonlinearity. However, the mathematical form, the regression itself, is still linear regression.